The points A, B and C lie on the plane pi1. Find the vector AB and the vector AC. Coordinates of the vector AB are coordinates of a point B, 0, negative 2, 0, minus coordinates of a point A, 3, 0, 0, and it's negative 3, negative 2, 0. Similarly, coordinates of the vector AC are coordinates of a point C, 1, 1, negative 7, minus coordinates of a point A, 3, 0, 0, it's negative 2, 1, negative 7. And the next question, hence find the equation of pi1. To find the equation of a plane, we know normal. It's any vector which is perpendicular to a given plane, and also we need a position vector of any point on the plane. And what about normal? It is not given, it should be found, and it can be found if we consider a cross product of two vectors A, B and AC, because a vector which is a cross product of two vectors is perpendicular to the plane in which these two vectors are. So let's consider AB-AC cross product. To find cross product, you can use a formula which is given in a data booklet. I use another formula with determinant over 3 by 3 matrix. It's determinant I, J, K, negative 3, negative 2, 0, negative 2, 1, negative 7, and it is equal to I plus I, and the determinant of this 2 by 2 matrix, determinant of 2 by 2 matrix, it's AD minus CB of AD minus CB, and it is equal to I, 14 minus 0, just 14, minus J, and determinant of this 2 by 2 matrix, it's 21, and plus K, and determinant of this 2 by 2 matrix, it's negative 3 minus 4, negative 7. And normal, it's a vector which is parallel to this vector, but for normal it doesn't matter its length, it's important only direction, so we can take any multiple of this vector. So we can see that we can divide each coordinate by 7 or negative 7. Let's divide by negative 7, hence normal is negative 2, 3 and 1. What about position vector of any point? We can see that A, B, C lie on the plane, hence let's take A, so it will be 3, 0, 0. And we can find the equation of a plane from the next equation, which is also given in a data booklet. R, it's x, y, z minus position vector of any point, dot product normal is 0. So it becomes x minus 3 times negative 2 plus y minus 0 times 3 plus z minus 0 times 1 is 0. It becomes negative 2x plus 6 plus 3y plus z is equal to 0. Negative 2x plus 3y plus z is negative 6. Notice that A, B, C, D must be integers. And the next question, plane pi2 has equation, the line L is the intersection of pi1 and pi2, verifies that the vector equation of L can be written as. So since the line L belongs to pi1 and also it belongs to pi2, and if it belongs to a plane, it means that if we substitute the coordinates of any point on the line, it also must be a point on the plane. So if we substitute coordinates of points on the line in the equation of a plane, it must be true. So, and let's rewrite for this line x, we can see that it's just 0 plus 1 lambda, or just lambda. Y is negative 2 plus lambda, and z is negative lambda. So we just substitute x, y, z in the equation of the plane pi 1. It is 1, so it becomes negative 2 times lambda plus 3 negative 2 plus lambda minus lambda is negative 2 lambda minus 6 plus 3 lambda minus lambda is negative 6 as required, hence it's true. And it must be true. And also we do the same for plane pi 2. So it becomes 3 times lambda minus negative 2 plus lambda plus 2 times negative lambda is, we can see that it's 3 lambda plus 2 minus lambda minus 2 lambda is 2 as required, hence it's also true. And the next question, the plane pi 3 is given by the line L and the plane pi 3 intersect at the point P. Show that at the point P lambda is 3 over 4, hence find the coordinates of P. It's the same L, so x is lambda, y is negative 2 plus lambda, and z is negative lambda. And again, since it's a common point, it's a point of intersection, it means we should consider simultaneous equations, and to find it we should substitute x, y, z for line in the equation of a plane and find lambda. So it becomes 2 lambda minus 2 times negative lambda is 3, hence 4 lambda is 3 and lambda is 3 over 4. And to find the coordinates of P, we just substitute 3 over 4 for lambda into x, y, z, hence coordinates of P are 3 over 4 minus 2 plus 3 over 4, it's negative 5 over 4 and negative 3 over 4. The next, the point B 0, negative 2, 0 lies on L. Find the reflection of the point B in the plane pi 3, hence find the vector equation of the line formed when L is reflected in the plane pi 3. So this situation looks like this. Plane pi 3, the line L and point P, it's a point of intersection, and there is a line which is reflection, and there is some point B with coordinates 0, negative 2, 0, and there is reflection, let it be point B1, and let its coordinates be x, y, z, and actually x, y, z are required coordinates of a point, and also P, coordinates of P are known, and let this point of on the plane BM, and also since equation of pi 3 is given, we can deduce that normal is 2, 0, normal is 2, 0, negative 2, so there is some normal vector, and due to symmetry, BM or BB1 or MB1 is perpendicular to the plane. And also we can represent BM vector as some coefficient, let it be k, and multiplied by normal, because BM is parallel to normal. And we can write that it's k multiplied by 2, 0, negative 2, or we can write 2k, 0, negative 2k. And distance BM is equal to the distance MB1, or actually BB1 vector is 2 times BM vector, and since BP vector can be found, and PB1 can be represented as PB plus 2 times BM, I mean that if we know K, we can find everything, hence we should find K. How to find K? If we consider PM vector is PB vector plus BM vector, and we can see that PM vector is perpendicular to BM vector, and if two vectors are perpendicular, dot product PM and BM is equal to 0. We can use it and hence find K. So we should find PB vector. Coordinates are coordinates of a point B, 0, negative 2, 0, minus coordinates of a point P, 3/4, minus plus 5/4, and plus 3/4. Hence it's negative 3/4, negative 3/4, and 3/4. Hence PM is negative 3/4, negative 3/4, 3/4, and plus BM, and BM is plus 2k plus 0 and minus 2k. And now consider PM/BM dot product, so it becomes negative 3/4 plus 2k multiplied by 2k plus 0 and plus 3/4 minus 2k multiplied by negative 2k is 0. K is not 0, we can divide each term by 2k and get negative 3/4 plus 2k, and negative 3/4 plus 2k is 0. 4k is 6/4, 6/4 or 3/2, hence k is 3/8. 3/8. Hence BM vector is 3/8, it's 3/4, 0, negative 3/4. It's BM vector. And we can consider PB1 vector, PB1 vector, it's PB vector plus 2BM vector, 2 times BM vector, and is equal to PB. PB it's minus minus, it's minus 3 over 4 minus 3 over 4, 3 over 4, and plus 2 times BM, so it's 6 over 4, 0 minus 6 over 4, hence it's 3 over 4, negative 3 over 4, and also negative 3 over 4, negative 3 over 4, it's PB1. And we need find the reflection, and we need coordinates of B1, and also PB1 vector, it's coordinates of B1 x, y, z minus coordinates of a point P. It's 3 over 4 minus pi over 4 and minus 3, negative 3 over 4 plus 3 over 4, and hence we can see that x is 3 over 4 plus 3 over 4, which is 6 over 4, which is 3 over 2. Y is negative 3 over 4 minus 5 over 4, which is negative 8 over 4 is negative 2. Negative 2, and z is negative 3 over 4, negative 3 over 4 minus 3 over 4 is negative 6 over 4, negative 3 over 2. Hence coordinates of B1 are 3 over 2, negative 2, and negative 3 over 2. And we need the equation of the line L after reflection, this line. And to write the equation of a line, we need a position vector of any point. We can take P and the direction vector, and we can see that the direction vector is parallel to PB1, and hence it doesn't matter its length, we can take any multiple of PB1. So as direction vector we can see that we can multiply by 4 and actually divide by 3, so it may be 1, negative 1, negative 1, and the position vector of any point, it can be 3 over 4 minus 5 over 4 minus 3 over 4, hence the equation of the required line is 3 over 4 negative 5 over 4 negative 3 over 4 plus some parameter and the direction vector 1, negative 1, negative 1. And that's all for this question.